Hi, my name is Lisbeth, and today we're going to be going over Boyle's Law, which is one of the gas laws in Chapter 5. So, Boyle's Law pretty much talks about pressure and volume. So, in your book, it states that pressure times volume equals a constant. That means that for any given volume of gas at a pressure, it's going to create a constant. It's going to be constantly the same value. But the more important part is the equation that we can get from Boyle's Law, which is P1V1 equals P2V2. Now, what's in their book, it also says P final, V final is equal to P initial, V initial, but as long as you keep the conditions together, it should be fine. One thing I do want to note, however, is that since pressure and volume are being multiplied together, that means their relationship is going to be inversely proportional. What this means is that if pressure is going up, then volume must be going down. And that makes sense because if you think of a container, right? So let's say I have a container in my hands and it has a given pressure. As I increase the pressure, I'm going to be pushing down, meaning that the volume of that container is going to be getting smaller. And the same thing happens if it's the opposite. If I'm releasing pressure, then the volume is getting higher. So keep that in mind as you're doing your calculations, because these calculations should make sense. You shouldn't have, if you're increasing pressure, you shouldn't have an increasing in volume. So I would go back and double check your answers if you have that going on. All right, so another thing I do want to note is that pressure should be in atmospheres. That's the unit it should be in, and volume should be in liters. Although for this particular problem, it's not super important to have your units be atmospheres and liters, it's a good practice to get into because when you get to the ideal gas law, it's just so much better to have it in those values. You actually need it to be in those values for the ideal gas law. So that's basically Boyle's law. So pressure and volume are inversely proportional. If one goes up, the other one goes down. Pressure should be in atmospheres and volume should be in liters. So over here I have an example. It says a 50-liter container of oxygen has a pressure of 15.7 atmospheres. What is the volume of oxygen if the pressure is lowered to 1 atmosphere? So notice over here, they give me 50 liters has a pressure of 15.7 atmospheres. So this is going to be V1 and this is going to be P1. And then here they give me another pressure, so that's P2. So that means I'm solving for V2. So I'm just going to go ahead and plug in those values and see what we get. And notice also they already gave it to us in liters and atmospheres. If let's say this was given to us in millimeter or centimeters cubed or milliliters, then I would have to convert that to liters. And if this was given to me in torr, millimeter mercury, pascals, kilopascals, etc., I would have to convert it to atmospheres. It's a really easy way to practice your conversions as well. So I'm going to go ahead and plug them in. My pressure one is 15.7 atmospheres. My volume one is 50.0 is equal to, my second pressure is 1, and then I have V2. So when I put those into my calculator, 15.7 times 50 gives me 785 is equal to 1 times V2. So when I divide by 1, that's going to be the same answer, right? So V2 is equal to 785 liters. All right, so let's see if that makes sense, right? So my original volume was 50 liters, and it went up to 785 liters. Since volume went up, I am suspecting that my pressure went down, which is true. I went from 15.7 atmospheres to 1 atmosphere. So I lowered the pressure, increased the volume. It makes sense. Boyle's law has, come to fruition, and everything is good. And that's basically how you use Boyle's law to solve a problem.